So, hello and welcome. My name is James Rice. I'm cybersecurity faculty here at Mohawk Valley Community College. And on behalf of everyone here at NCAE Cyber Games, we welcome you to our first and hopefully first of many monthly streams that we can start getting in the ritual of doing here as we prepare for this next competition season. Some of the things we got on our lineup here for tonight are to speak with our lead CTF developer, Mike Lisi, who's on the stream with me as well as see some bloopers and talk about some of the funny things that happened last season at our last competition in spring. A couple other things we got lined up is to get a little bit behind the scenes with some of the cybersecurity clubs as well. We'd like to make that a reoccurring part of the stream, and so I caught up with the local Mohawk Valley Community College team and got to meet some of those students. So there's a few of those things and more, and we'll see what we can have some fun with here over the course of the next hour. So, Mike, my counterpart in crime, welcome. How we doing tonight?
Hey James, yeah, thanks. As you said, Mike Lisi here. I'm in charge of the CTF component for the CAE Cyber Games competition. Basically, I'm here tonight to talk about that event. And my job as part of the competition is to create or oversee all the challenges that are used within the event. Try and keep in mind that our goal is to keep things fun, interesting, and challenging. My introduction to cybersecurity began with CTF competitions, specifically the DEF CON 19 qualifiers. So I've kind of been involved with these for quite a while now, and it's just one of those things that I really enjoy, participating in or running ever since that initial, introduction, 11 years ago now.
Yeah, exactly. And it kind of reminds me too, as you're saying that, you think back over the years, and I'm thinking to the rest of our team as well, how many of the people who work on this project, like so many of them have similar stories of, I started at some competition locally or some kind of crazy, weekend hacking experience, and then all of a sudden here we are years later, developing and trying to deliver the same experience, this fun thing that we're really passionate about for students across the country. It really just has been kind of a surreal ride in that sense. Um,
Yeah, I agree.
yeah, so I guess perhaps to get started here, especially if we have any kind of new people sort of tuning in for the first time, I'll just take a few minutes to do a little bit of recap of what our event was kind of all about and what some of the students experienced last year. So if I can do a quick screen share here, if you haven't been to our website, I think our website kind of tells at least the quick story, the 2 minute version, the TLDR version. You can see we've got a handful of different students that showed up and competed from across the country. That's really what this event was all about. We ended up having a whole bunch of different regional events over the course of a handful of different weekends in the spring. And out of those regional events, we were able to, as a team, go and pick, okay, these are the people who are going to make it to our actual finals that we can spotlight. And so we were really proud of all the different activity that we saw at our regional events. There were a couple other wild card teams that we ended up throwing it in there so that we could have a nice round number of 10 teams at our finals. But nevertheless, this is what the lineup was all about. And so these teams competed and either won their region or really displayed something really awesome that we thought was worth inviting them to the finals. And so we did. And so that's kind of what we had for our finals event. The overall, spoilers, the overall winner of our finals event, I believe, was the Illinois Institute of Tech. So we were really proud of them. They definitely had an awesome showing here for the first time. But really, any of the teams here on this list, these are some of the teams to watch out for this coming season. I'm sure. Just to see, like, they at least have the experience of what it's like to make it past the region, make it onto the finals, and kind of get that get the pressure of having to do this on the big screen type thing. So as a preview of coming events of what we're trying to have roll out this time around, we're hoping for something similar, just with the big twist this time that, yeah, we're definitely looking and planning, knock on wood, COVID provided, that we'll have an actual in-person finals this time. So again, it's a similar format. We'll try to see, again, details will be released as appropriate, but nevertheless, we intend to have a whole bunch of teams, a whole bunch of regionals compete in the spring. We'll be able to pick some winners and however many that we can accommodate and actually have something similar to before, but hopefully bring an actual live in-person element to the show this time around. So I don't know, Mike, is that pretty a good summary anyways of some of the things we encountered last time?
Yeah, no, 100%. And, we've run this competition locally for a number of years here, and the in-person component of it is something I'm really hoping that we can do this year. It's in place right now. I'm really looking forward to it. It gives me a lot of ideas for fun things that we could do that we can't generally do in a fully remote event. So fingers crossed.
Yeah, exactly. And it does remind me how going from some of the local events to the national event, how there definitely were some points that were like, oh, how are we going to do this when everything is completely online? Or the flip side of it, of like, oh, hey, everything's online. This is actually really easy for this part to work. Like we don't have to worry about herding cats all around campus, like we oftentimes do at the local event. But nevertheless, it's all in good fun. It has, and it definitely was good to see the schools come out, from across the country. It's really been awesome to see. So all I can really emphasize to anyone watching is like, hey, if you can get some more students, some more energy from your colleges, even just from other colleges in your area to try to jump on and compete, we're definitely hoping to grow this, and by all means, the more the merrier. We like to see the little bits of rivalries and all that going on. So hopefully we can have some more of that happen this season as well. So if I want to get perhaps a little bit more technical of some of the details, our competition is really formatted and scored. If you're thinking about how did the winners get to where they were, we format our event and score our event in really two big categories. One of those categories is CTF, and obviously I'll let Mike talk about that. But the other category is what we call services. And the general idea of services is that we present all of the competitors with an entire topology, an entire list of servers for them to go out and defend. And a lot of these servers that they have to defend are in, let's call it, varying states of functionality. So some of them might be working, some of them might be, well, sort of working, some of them, well, okay, good luck. We were, maybe a little mean with a couple of them, but hey, that's what the challenge is all about. But either way, a big part of it is, can you get your services working? Can you get your little part of the network working? Just like you're trying to simulate, what if you worked for the government, for the military, for the NSA, for just a private business, for a hospital, for whatever the situation might be. Everyone's got some type of network topology and infrastructure, and it's what can you bring online, and let's see if you can make your services available. And of course, the really crazy part about that part of our event, which is a major scored part of our event, is that the environment is contested. And this is where we introduce what we call our red team. So the red team, of course, is anytime you have cyber competitions, we usually refer to the red team as the malicious element. And so we do have malicious hackers. I like to think our hackers come with a smile, and in the sense that they're at least a little bit nice. They're not entirely there to destroy your day, but they certainly can feel like that from time to time. So realize those servers that you're bringing online, yeah, you do have to face live attacks throughout the entire day. All knowing that that we're putting on this event for first-time competitors. So yeah, it can be pretty daunting to take this on. This is why it's a team event, but that's a major portion in what we as cybersecurity professionals are really in training to do, is to say, can I be put in charge of some infrastructure and deal with the threats that are out there just by plugging my device into the internet and connect to the internet? Like, yeah, we all have to face threats. And so that's really what we're trying to do. So that's a big part of our event. That's what we call, like I said, the services part. There's a lot to learn and a lot to prepare for that, but that's not our entire event. We also have on the other side the capture the flag. So Mike, why don't you give us a little bit of a description of kind of what that's all about and how that complements the services, and kind of what you saw a little bit of last time.
Yeah, for sure. So if you're new here, the CTF, Capture the Flag event, it's how these types of events started. The premise is kind of that you as a competitor are presented with a set of challenges, different types, different categories, and they have a point value associated with those challenges, typically associated with the difficulty of the challenge, right? So anything that's more difficult will be worth more, but at the same point, it's going to be a lot more challenging to solve. And then when you solve that, you submit the flag, you get the points, and your team goes up in rank. We have both components as a way to provide content for everybody that's competing to participate in some different way, right? So if you're coming at this as a very first time, never done a competition sort of a student, that's our intended audience. So we have stuff on the network side that is a little bit more challenging, as you said. And on the CTF side, I have content that we put into that's completely approachable from literally any perspective. So as simple as, some of the stuff is just trivia types of challenges where you can go out, you can Google, find the answer and get your team some points. In other cases, we've structured the event so that things that occur on the CTF side are relevant to what's happening on the network side. So there's a lot of communication component that needs to take place, right? It's a team event. We try not to just silo everything off onto two different sides there. So some of the things that you learn during the CTF may be of use to you on the networking side. Um, when
And
we first started
Mike,
doing this,
if I could just jump in
sure.
there for a second, that balance that Mike was just talking about, I want to say that is one of the main reasons why every single one of the teams that's on this list right here on the screen made it there, is because they were able to, as a team, find the balance between solving some of those problems and dedicating some of the resources to fixing the services. So realize that you really have to figure out, like, how can I, as a new member or as a first semester, second semester student, work with the rest of the people in my team to, like, put my brain power together and try to solve the available challenges. And we definitely saw some of the teams that fell short of this list. Maybe they just didn't do that as well. They might have had a good time, they had fun, they learned a lot, but being able to devote your time as a team appropriately and efficiently definitely makes a really big difference by the end of the day.
Oh no, for sure. And really that's kind of intentional, right? The scoring that happens on the network side, the service side is like accrual. You get points throughout the day continuously as you keep things online. On the CTF side, there's points that you can gain, but it's kind of a one-time deal. So you really have to, play it out. When do you want to commit your resources to either one of these things? Because every service check that your team misses, there's no way to get those back. Whereas everybody can kind of be on the same page with the CTF points and just get, there's kind of the same cap there. So there is some strategizing that needs to go into it as far as resource allocation. And yeah, it's kind of intentional that we did it that way.
Yeah, and I will say too, if it sounds a bit overwhelming, don't worry. Every other team is dealing with the same pressures you are, and that's definitely a big feeling of, like, why would I, as a new student, want to subject myself to all this? Because by the end of the day, like, your brain is on the floor, you just can't think anymore, But you realize it's like it's not necessarily an experience you can really get in the classroom or outside of this. Like, this is why we as cyber professionals are trying to purposefully subject ourselves to these big pressure type tests, is because you can really start to stretch yourself and see what you're made of, and then realize, like, in reflection afterwards, okay, what were the things that I did well? What were the things that didn't go so well? What were the things about my teammates, like, hey, it was really useful when you helped me with this, or vice versa. And those experiences are really just invaluable as you're developing as a professional. So
I'm totally on board with you on that too. I think that, the CTF part of it for me is one of those situations where the actual flag ends up being, just the end of the journey, but the journey itself is kind of the whole point of it. The challenges are developed to expose students to different sorts of things that they're going to encounter in a way that, kind of presents them with a solvable challenge, right? It's something that's been designed so that you have the ability to figure out, the component that's kind of being tested here, and hopefully learn something that might pique your interest and kind of send you down like a journey of a new concept that you weren't aware of before. For me personally, like, I learned a lot about cryptography and crypto challenges just from doing CTFs. And that was an area that was, previously something I kind of stayed away from.
right, and it definitely reminds me of how, at we didn't see this at the regionals because we didn't have all the students on webcams, but at the finals we had all the students on the webcams, and so you could actually see some of those, like, awesome woohoo moments as they spend like 90% of their time in confusion and frustration as they're like, how the heck did Lisi put this crazy challenge together? And then there's the aha moment where it's like 10% of figuring out and solving it and high fiving. And yeah, those, trust me, that little 10% moment, those really make the entire experience worth it. So,
For sure. Yeah, we had some great contributions last time too. There was some challenges that were developed by professionals in the field. We had some actually some of the most highly regarded challenges in the event were developed by other students, right? So they were learning things in their classroom or on their own, and they developed some really useful challenges that was in line with what we were shooting for in the event. So it was really nice to have some other contributions coming in for that.
So, on that note, perhaps we'll transition over to take a look at what you can do as an upcoming competitor or even just a returning one to try to practice some more of this stuff and perhaps do a little bit better maybe than you did last time, or pretend that you're going to show up before the event with a little bit of practice. Not to go professor mode too much, but let's just say I saw a lot of students doing their homework the night before things were due. Anyways, we do have a sandbox here on our main website that if you've created an account with us, you can go and deploy some things. I think this is what we'll take a look at here today. Mike, right? You have one kind of lined up for us to check out in the actual capture the flag category. So what Mike is kind of going to demo here is all built off of something that you can do yourself as part of our capture the flag challenge in our sandbox environment. And if that makes sense, then I'll have you kind of go from there, and we'll talk about that challenge for a little while.
Yeah, for sure. So, this for our first video here, I decided that we would kind of walk through a challenge that's in the sandbox right now. So anybody that's, interested in doing this on their own, they can sign up, they can get in the sandbox, they can walk through this and kind of figure out the process for solving the challenge. I mentioned crypto before. That's going to be the first topic that I'm going to cover in this series of videos here. And I'm going to preface it with a little bit of information about crypto in general, and then some expectations for the competition. And we're talking about cryptography here, not cryptocurrencies. We're not doing anything related to that. So why are there cryptography challenges in a security event, right? That's one of the questions that, some of these students may be asking. Well, at its core, cryptography is a way that, information is being protected via the confidentiality or maintained in the integrity to make sure things aren't getting tampered with. And this is something that's, been important for thousands of years. Some of the oldest references to cryptography date back to 1500 BC, where they had literally a stone tablet that had an encrypted recipe for pottery glaze that this craftsman didn't want to, have anybody else understand the process. So it was a way of, protecting that information. Nowadays, everything's kind of like, it's all done with these advanced algorithms, a lot of really intense math that's involved with it. So there's kind of two different distinct categories of cryptography. There's the classical stuff, which is kind of the areas that I target when I put together challenges for the event, because those are more approachable from somebody that doesn't have, that background or that experience in the higher level math. But the concepts are kind of the same. So if the goal in cryptography is to protect the information, then if you have a way to break that protection, it may give you an advantage. So, for instance, if you have there's a conflict happening, your enemy is sending encrypted communications to their allies, and you have a way to break that and see what's going on, you're going to have an advantage, right? This is what we saw back in World War II with the Enigma, the way the Germans were transmitting messages to each other, and the allies, they found a way to break that, and now they had this information that they could act on that the Germans didn't know that had been broken. So it really had a big impact in how the war went. So for those reasons, it's important to kind of make sure everybody understands how crypto is used. And in that way, we develop some challenges for the competition. So going back a little bit, we have some challenges in that CTF environment on the sandbox. So we'll pull this up here right now. And the one I'm going to be going over is called Crypto 201. So once you're logged into the sandbox, we have 9 CTF challenges right now that you can go after. The one that we're going to be talking about right now is Crypto 201. So I selected this one for a couple of reasons, right? First of all, it demonstrates real world crypto use. And two, it's completely solvable without any tools, right? You can just make some simple deductions to get the answer. So if we take a look at the challenge, one thing I want to point out is that all the information that you need for this is generally provided in the title and the description or in the attachments, right? So use all that information to your advantage. In this case, the title just says Crypto 201, not very useful. And the description basically just says decrypt the secret message and capture the flag. And we have 3 files that are attached to this. We have one that's called message.txt, one that's called message.inc.txt, and one that's called secret. So you can click on each of these and it'll show you the files themselves, and you can download them to take a look. So let's just discuss like what information are we getting from the file names themselves? What deductions can we make from that? So James, any kind of thoughts off firsthand on what we're seeing from the downloads here?
Yeah, so definitely something that always jumps out at me, and anytime I'm doing CTF is like pattern recognition immediately. What about the names might be somehow give it away? Like again, the crypto 201. Sometimes even just the name of the message can really give it away. Things I should be looking at. But definitely the files themselves. It's like okay, one of them's called message and one of them's called message inc. Okay, maybe those two things are related somehow. And then of course you want to do the opposite and say, well, what's the odd one out? All right, and so how can I then take the one that says secrets and relate it in some way to the other things that might look the same. So again, this is kind of what Mike I think was talking about of, anytime you're doing crypto, a lot of it comes down sure to technical skills, but a lot of it is not. A lot of it is just can you figure out puzzles and do pattern recognition and stuff like that. So those are definitely some things that pop right out to me. Definitely when you clicked on some of these files too, there was some intelligible information such as in this file. And in the previous file, I'd say there was some, well, let's say less intelligible information. So a thing that I'm kind of processing as you're saying this is like, okay, take a deep breath. Be prepared to see some things that I have no idea what the heck this is. Like that's half the point in figuring out the puzzle. If it was obvious, it wouldn't be a puzzle. So I don't know. Those are some things that immediately, just with what you've said and as you're talking, like they jump right out at me like that.
Yeah, no, you're exactly right. So you're right on target with that. So the message here, we have a plain text message. It contains a whole bunch of string. It's a whole bunch of words. It's kind of weirdly formatted, but it's something that we can read. It's our plain text message. Now we have this message inc file, which looks like a bunch of random who knows? It's just a bunch of hex values, right? But if you're just comparing the two file names. Yeah, you're right. The message.txt is our plain text message, and message inc is our encrypted version of that same message. So let's just start with those. So if we look at message.txt, we have a few lines here, a dozen lines or so, a bunch of words, and it's kind of they're all kind of formatted, padded out here, and it's definitely kind of interesting here. We have five words, 13 lines or so. So that's our plain text message. Now, if we're looking at the encrypted message, it's kind of formatted pretty similarly. We have these hex strings, and it looks like kind of a similar layout, right? There's about 5 across and another dozen down. So there's definitely a correlation that can be made here. So we're gonna take a look a little bit closer. So what I did is I downloaded these files and I threw them into a text editor so we could take a look at them a little bit more closely. So here's again the plain text message file, and then what I did is I separated out each word individually. But let's take a look at each one here. So what do we have that's unique? So we have essentially a word and then a handful of spaces, and it's all kind of padded out the same. So if we look at the size of this, it is, as it says here, 16 bytes, right? 16 characters. And character, a byte, 8 bits. So that gives us 128 bits of data in this, essentially this block, this one word. And if we go across, we see that, in fact, each one of these is 16 bytes, right? These are all kind of padded out to 16 byte blocks. Okay, great. That's a little bit of information. How is that useful? Well, if we look at the encrypted message, we have each of these blocks was 32 hex characters, right? So 32 hex characters, each hex character is 4 bits. So again, we have 128 bits of information on this. So the deduction that we can make for this is that, we have 128 bits of data in each of these words and 128 bits of data in the encrypted. So we can kind of associate that, we have a value for a word and its encrypted counterpart. Great.
So pro tip out of all of this is if it's spaced or organized, pay close attention because there's a big difference between tabs and spaces.
Huge
And
difference.
and
Huge
that
difference.
that
Yeah.
definitely makes a big difference for problems like these.
And that comes down to like everything is formatted in this way for a reason, right? There's a reason that this is here, and that should kind of stick out a little bit. Okay, so if we're looking closer at this plain text message, are there any like specific components that kind of stick out as being like what other information can we infer from here? So we can see here that we have like the word keep is appearing a few times.
Hmm.
We have the word will, right? So we have these things here. So let's reformat this one into the second message here so we can associate each one of these blocks, each one of these strings into its own line. So we can kind of correlate all this stuff out. So like I said, we have these words like will, and it's in here a couple times. So the 24th word and the 35th word. Okay, well, let's look at the encrypted one. Let's take a look at that here. So the 24th word starts with EC, E0CC, blah, 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 and ends with EF5. And if we look at the 35th, we can see it's exact same, right? So we're seeing that now that's kind of reinforcing the fact that our plain text message is reflected here in the encrypted message. So we can take this string, this E0CCC, and associate it with the word will, right? Because they all kind of correlate back.
So we're really kind of reinforcing a crypto technique that we've seen over the years, which is a lot of times when you take your original messages and you scramble them, if you're using the same technique, well, then the same message gets scrambled the same way. And
Yeah,
that's
if
kind of
we're if we're
what
gonna
you're
get
pointing
into
out.
like the weeds a little bit on this, this is what's called like it's encrypted in what's called ECB mode,
Hmm.
which basically does the encryption individually on 128-bit blocks. So therefore, if there's no randomization between those blocks, then a block that's identical in two different places will encrypt the same way with the same if you're using a key for that. And this was a flaw that was discovered after the use of ECB mode because it was done because it was very fast because you could kind of encrypt these blocks individually. But then later on, some evaluation of this showed that, oh, if I have the same data, then all of a sudden we have a little bit of a problem because things aren't getting encrypted in a way that's not reversible, right? You can kind of correlate blocks to known values if they appear in multiple instances.
And just as a point of trivia for others, like that is part of what they were using when Mike was talking about the Enigma machine earlier, was taking known messages and trying to break things that way. So yeah, things like this, these types of attacks have definitely happened in real life and were part of breaking actual codes.
Yeah, it was a huge part in the Enigma situation too, because the way that the Germans had transmitted messages, I believe they had like the same kind of format or the structure at the beginning of their messages. So they could only decrypt, they only need to decrypt a little bit to understand like, oh, hey, we found the actual key for this because it's giving us a value that we're expecting to see
Hmm.
versus, if we can't associate it to anything specifically, then it makes it a little bit more difficult. Okay, so we kind of correlated that we have a plain text file, we have its encrypted equivalent, but now that leaves the secret to the secret file, right? Which again has all these similar size blocks, 32 hex values, 128 bits. So using the information on here, what kind of deductions can we then make? Because we don't have the plain text version of this secret message, but we're trying to figure out what that is.
I gotcha. Okay.
Yeah, so let's take a look. So as I said before, we had this message to which we could correlate back. Well, let's look at like the values in here. So we have this first line here. It starts with 34, 34B, 92B. Let's look back at this other file. And if we look, we can see that we have this block that appears in that encrypted message file at it's the 21st block here. So if we go back to the first original message and we look at that value, we see the word count. Okay, so that's interesting, right? That might mean something. So let's go back and look at this next block. So we have the 7D, blah, blah, blah. We take a look at that and we see, okay, now we're down in, space 54, block 54, we have the 7D, and now we can correlate all this back to our plain text. So, and that associates the word the. So now what we're doing is taking what we have as known, like this known plain text version, its ciphertext equivalent, and we have the secret message, which was encrypted in the same way using the same key, but it contains data that has been encrypted before. So now we can actually decrypt this entire file without knowing the original just by associating it back with the encrypted file of our message and the original message itself.
Right. And that's really interesting how, as an attacker, I can try to record traffic that I don't really care about, but if it gives me a reference point, now it becomes valuable in decrypting and attacking the traffic that I do care about. Which is
Yeah, and
definitely
that's a
something
huge
we're seeing
concern
here.
right now in privacy because, like, if you're able to capture all that traffic now, even if you can't decrypt it now, if you could decrypt it in the future, now you have, all this data that you've collected, and now you can run, whatever tooling or whatever methods that exist now to break that to, essentially decrypt all of that information and gather whatever was inside of that. So it's definitely something that's still useful. Um, just in computers and networking and everything today.
Hmm.
So if we go through all of this and we decrypt all of these, I'm not going to do these one by one, but suffice to say, all of these exist in the encrypted message file, and we can associate it back. So the end result, if we did all these, is the first one is count, the second word is the, and actually interesting in here is that if we look at the 7D, it actually appears multiple times, right, in
Hmm.
the same file. So we've kind of broken that word in two spots. So we know that we have the and then some other things and then the again. And in fact, there's some more repetition that occurs here. So we have this 1A and 1A.
Work
Uh,
harder, not smarter, Mike. Come on.
yeah,
I got to go
why
check them
keep
all
doing
one
that?
by one. What are you talking about? I'm
Yeah,
not going to notice
exactly.
all that on the day of the
Um,
competition.
so yeah, we go back. It's number 44. So we have the words. So now we're like slowly making this is all making sense, right? So that's the next part is like as you're going through this, does like the process that you're following seem to make sense, right? This
Mm.
is definitely looking like a message that we can make use of, right? And spoiler here,
Hmm.
the next one is number and number of words. And actually, I forget what this one was. I think it was submit. Uh,
37.
37. Oh, send,
Send.
send. And then we have the number again, right? AA0. So we have that one.
Mm.
So I made this so that it's a little bit, you don't have to, it doesn't get too bad. The 567, we have a repeat there. Um, the number of,
Now, kind of as you're finishing this challenge out,
yeah.
is this challenge similar to some of the ones that we had at our actual competitions at the regional and finals?
So it's similar in the way that it's approachable by anybody. It doesn't use a lot of really high level math types of challenges, right? So typically, what you're going to see for the event is going to be more on the classical side of cryptography, just to understand the concepts that were used, the techniques that were used, and can associate that with vulnerabilities, essentially how those different techniques can be broken.
Hmm.
In some cases, there's already tooling that exists to break these, right? You're not expected to like write a novel program that's going to crack all these, but more to identify what the concept is and then to find the right resource in order to help you solve it.
Hmm.
So our final message here, if we look at the end here, it says count the number of words and send the number of words as text. So this is a little bit ambiguous here. So what words are we talking about? So there's like a little bit of a leap that you have to make here. So the only words that we ended up with were in this original message, right? These
Mm.
are the only words that we were provided. And if we broke it down, we saw that there was 64 words. It says send that as text. So if we go back to our challenge here, we see that there's directions on how to submit it. You have to prepend it with the word flag. And then we have 64 as our string, and we submit and we're correct. So
Woohoo,
that's our
yay.
walkthrough on a crypto challenge that
Hmm.
didn't take any actual tooling to solve, just a few deductions and noticing the patterns that are taking place. So James, what do you think about that one?
So definitely, I like the idea here that you're touching on a lot of just relevant security or cryptography concepts and concerns kind of at the same time, that just for the viewers and for the students taking on the competition, like these things continue to pop up again and again. Like, don't think, oh, Mike showed this problem, so every professional everywhere never does anything like this ever again. Like, well, no, actually, things like this do happen. And part of what we're trying to think about here for sure is like, well, how can we identify the patterns and make sure that we're not doing things like this, or we're not using algorithms that can kind of fall into this trap. Also, as you're talking about a lot of this, I'm definitely like cranking away numbers and using some other, let's say, more technical techniques in my head to say, oh, here's maybe what I would do to kind of get to the same point.
Mhm.
But not necessarily. I'm not going to pretend like it's easier or that it's this is a common problem I often share, is that part of the problem with clever people is that they want to come up with clever solutions and they want every problem to be clever, when sometimes what you just showed is like, hey, that's actually a pretty good way to get there. And during a competition, when there's a limited amount of time, and you're playing these games, that sometimes the time actually matters. So I don't know. Those are some of the things I'm immediately kind of jumping out at. And I don't know. Maybe it'd be worth kind of walking through some commands to kind of make it tangible.
Sure.
But just kind of keep that in mind, that like just because I show a command doesn't mean like, well, you should go memorize it this way. It's more like, this is just some of the crazy, yard or lines of string, the red lines of string going through my head might be connecting things. But anyways, so what I'm really trying to say is what Mike is doing is showing you a nice way to do this, that really is for children. And if you want to path through this difficult challenge that has a little bit of chest hair on it, then maybe you could take on some of the more technical ways you might going about doing this. But hopefully, by kind of tossing out some of these ideas as he's talking through this, you might pick up a few techniques and see why is it so valuable to, the more command line you can learn, the better. The more Python you can learn, the better, whatever. And so feel free to critique my thought process. Like this is, I don't pretend that any of this is refined. It's just some of the things that I immediately noticed when he was talking through it the very first time when I saw this problem. So some things I'll emphasize is how about I'll take the things that you started with and kind of show how I would have worked through a lot of this, definitely in a technical way. But again, I'm not pretending that this is necessarily better. It's just
Sure.
it's another way to approach it.
Yeah. Yeah, absolutely.
So I think the files that you started with were what, the message-enc.txt, the message.txt, and the secret.
Yeah,
Um,
that's correct.
so I think what I'll do is I'll take those out of downloads, and I'll just put them in my home directory. So just so that I don't mix and match any of the things that Mike did here in this directory, and I'll toss them more just kind of in a folder of their own. So how about I copy those over? We have the message dash encrypted.txt. We have the message.txt, and we have the original secret.txt. And I'll put all of those just in the home directory. So if I go back to the home directory, we should see like, okay, there's the files that he actually started with, the message, the encrypted, and all that. And as he's looking at data, and this is kind of, I think, a big tip, realize, data can be looked at in a lot of different ways. And so when he very first clicked on this, like, this is how the browser shows you the data. It's like, yeah, okay, but how does another program show you the data? Those are also, just other good things to keep in mind. He opened up another like mouse pad type program. It's like, well, how does the data look in here? And so it can always be beneficial to take a look at the data in a variety of different ways, and don't pretend that this is the only way that you should be looking at it as your very first way. So not only can you try to make correlations, but just anytime you can look at a problem in a different way, I think a lot of that oftentimes helps. So how about I just take a look at the data right here at the command line and see what happens when I start just spitting out files at the terminal. So if
Yeah.
I do things like the original message that was encrypted, or the encoded one here, .txt, and just cat it out, it's like, okay, there is a big mess of stuff that doesn't look too pretty, but like it's all there, and I sort of see the spacing, and like, okay, fine. I could do the same thing for the other one, the message.txt, and see, well, that one's formatted a little nicer, but still you kind of have the same general ideas, at least, not really a major benefit for that one. And then what was the last one? The secret.txt. And so again, I'm just looking for initial pattern recognition and sort of seeing how, yeah, the secret does kind of look like that nasty wall of text that the first one was. So I think even just by looking at the data this way, you can start to make these correlations between the data, even though you weren't looking at it through a browser, weren't looking at it through like a WordPad type program. Some things that I also immediately thought when I very first saw this was ugly data. Ugly data. Hey, this is a little nicer. Maybe I could start to make them all look a little nicer. So even just that hint right there of like, how can I try to make these things look a little nicer, especially if I'm sort of in the weeds, let's say, with working at the terminal or working with some program, approaching the data programmatically. And so something I immediately thought was, okay, anytime I'm dealing with data, it's usually easier to deal with the data if it's all in one row or if it's all in one column. And programmatically, when you start having blocks, you get two-dimensional type ideas. And how about I can limit it down to one dimension? And so now we're getting a little bit more advanced of like, well, and this is exactly what Mike did, which was how do I go from something like this to something like this, which is much easier to deal with. And he's got the line numbers, which obviously that was a really good idea and a really good critical part of coming to the solution. But it's like, well, how can I do that here at the terminal? And I don't pretend that there's only one way to do it. But one common way that I'm often looking at is, can I take the data and instead of having the data spaced out, can I replace that now with line breaks? And so what I'll do is I'll take my message using like the sed command, which could do find and replace, and say, how about I do a find and replace on the spaces in the file and then replace them with line breaks, which would be my \n, something like this for the entire file of my, I'll just start with the encoded message one, something like this. And so you see if I spit out the data this way, now using a little sed command, I've replaced all of the spaces with line breaks. And it's like, hey, now I'm getting closer to what I'd rather work with, which is data that's either in one column or data that's all in one row. And if I want, like, again, why work off this original file that we had? And this is something I see a lot of CTF students kind of fumbling with many times is like, well, I started with a problem, so I must go immediately from problem to solution. And if I don't get there in one step, I must not be smart enough. It's like, what? No, not at all. So anytime you can take it and start to create like intermediate, I want to inch my way as small as I can towards the solution and then eventually get there. So I could take this output and just make a new file, and that's obviously what Mike did when he went through his, non-programmatic way. So, toss it in a new file. It doesn't really matter how you want to write the data, but maybe I'll come out with my message encoded 2.txt, something like that. And so now if I cat out my message dash encoded 2, it's like, hey, great. Now I've got another file to work with, and I can work with it more in like a column type format as opposed to the, all vertical. Now the question becomes, well, maybe I could do that with all of them. Take information out of the block and put it all in the column, and just see what happens. Can I kind of rinse and repeat and do sort of the same thing? What were my other files called? I had just message. So maybe I'll try that with that one, like sed. We'll do a find and replace of a space. And we'll toss in line breaks instead of spaces on message.txt. And when I do that one, it's like, well, that works, but remember, Mike said each one of these was formatted to be exactly 16 characters. So every one of those spaces, like we were talking about earlier, like, oh yeah, this spacing kind of matters. So it does kind of work, but again, it's not perfect. All right. So, okay, fine. So how can you maybe start getting rid of these? And this is where we definitely can get into some ideas of some things I've covered in some of my Sandbox tutorial videos of taking your output from one command and maybe sending it to another command. So without making the sed command more complex, I realize there are some ways you might be able to get around that. But without making it more complex, I'd like to just kind of use this opportunity to show how can you look specifically for like blank lines of information. And actually, grep has a pretty nice way of doing that. And so with grep, you can look for something like this, a regular expression that starts and ends right back-to-back characters. So again, I won't bore everyone with all the tech details, but anytime you search for something where you have this hat, the shift 6, and then a $, that says the start of the string and the end of the string, they got to be right next to each other. So in other words, you get something that's empty. And so if I take my output now and send it to this, you see, well, now I found all the blank lines. So it's like, okay, great. Well, actually, I want the not that, right? I want the not blank lines. And so it's good to know with the grep command that you can actually take the inverse of what you found using -v. So instead of finding everything that has a blank line, well, to find everything that has a blank line and then throw it away. And so now you get pretty much that same exact formatting of data. But again, you're kind of tossing a sed command and a grep command together. And, Google can tell you how to do a lot of this stuff. Don't pretend like I have to memorize all these things off the top of my head. It's like, no, how can I find spaces? Okay, Google will tell you. How can I eliminate the spaces? Okay, Google will tell you. But again, after I've done all this, maybe I'll toss this in a news file as well. Message2.txt, something like that. And so now if I cat that out, message to, it's like, hey, great, now I've got some files kind of like more what Mike was working with, and we were able to kind of get there using the command line, and I didn't have to sit there for an hour kind of retyping them or doing anything like that. I got one more to go. Let's see how we do on this last one. If I cat out, what was it, the secret message? Yeah, this one. Maybe I'll try that same trick again of doing sed, do a substitute of space for new line globally on my secrets, and you'll see, well, this one isn't quite as like, wait, I thought I got rid of all the spaces. What's going on here? Well, I'm gonna try to eliminate some of these using the grep command. You'll kind of see that this might flub a little bit. Grep-e, kind of the same little trick I just did before of doing the -v, and it's like, I kind of got the same result. So what I'm going to do is I'm just going to save this sed result, and we'll kind of explain why, a real common thing that can happen when you're working with your files here. And maybe, Mike, you can confirm, like, yes, this is indeed what I was thinking, secret2.txt. All right. So I know this one isn't perfect, right, this secret2.txt, but we're kind of swinging back to, well, look at the data in multiple ways. Because if I look at the data this way, just by catting it out, it's like, well, I have some spaces, and I thought I got rid of them, and they don't seem to be getting rid of. It's like, well, then why don't you pop open the file some other way? Open it with Nano, open it with Vim, just take a look at the data some other way, and it'll kind
Yeah.
of reveal what will happen with it. So, Mike, am I on the right track here with
Yeah.
what will happen? And it's like, oh, you've got some other character in here. And so, yeah, replacing this with just a space, there actually is another character. So, Mike, what do you know why? Like, why would this character actually show up here? I'm kind of curious if you have a reason as to why. I think I know
Um,
why.
I I don't remember the exact reason. I think it's some association with the type of file like being done in Windows or something, but
That's
I
what
can't
I was gonna
remember
guess.
exactly.
Yeah,
Yeah.
that's exactly what I was going to guess, was probably the files were created in Windows, and now Linux just reads them a little different. So again, another pro tip, the actual enter button for Windows, the new line character for Windows and Linux, is not exactly the same. So if you have files that you send back and forth from one system to another, you can get these other little artifacts of other characters that actually get left over. So, but I just deleted them out manually. I could go searching for them, but whatever. Delete them out manually because there was only two of them, and I'll do my escape :WQ and save that. And so now I've got a nice little, okay, yeah, it's formatted nicely. I eventually got there. So
Yeah, I manually just went and, deleted all those lines. So yours was way faster.
So now I've kind of got sort of the same point that Mike had, which was, okay, I've got my message, I've got the encrypted stuff, but it's all nice and neat in one column. And so now kind of a question becomes, okay, is there some crazy way programmatically, because I don't want to sit there going back and forth between all the files and sort of compare them from one to the next to the next? And the answer is kind of like, well, how good are you at Python? How good are you at Bash? How good are you at sitting here writing some little script that could start comparing things? And I don't pretend that this stuff comes naturally. You got to practice it. You need little problems to practice it. So Mike's way, yeah, probably faster than maybe trying to build something and fumble with something like this for a while. But it is a good thing to kind of to work towards sort of in the end. And perhaps kind of where I'm going with this is I might want to start taking a look at every single one of these lines that's in my secret file and seeing, are they in the encoded one, right? The message dash encoded 2.txt, being like, okay, here's maybe where I need to like go find them out of. This is my library that I'm kind of looking through. And so part of the question is like, well, how good are you with the loops? How good are you with going through all the different data and actually seeing, can I check these one at a time to see if it's actually in the file? And again, there's a whole bunch of different ways that you can approach this. I don't pretend that this is a good way or the most efficient way, but it certainly is a way that, might work for me. So I'll start with this like secret idea, the secret2.txt, and say, if I cat this out, I've got all of them. And now I could toss this into a for loop to go through each line one at a time. And again, most of the time I might like take the time to write an actual script, but just kind of for simplicity or for just the the stream tossing them all here on one line is more the direction that I'll go. So I don't have to worry about how do you make a Bash script or how do you make Python scripts, whatever. So your general syntax would be something like this, like for line in, and then you'd have to say where are you getting your data from. And I'd like to get my data from every line in secret2.txt. So I can do the result of like cat secret2, secret, let's spell it correctly, et2.txt, something like this. Put a semicolon and then say do. And now I can see what is this actually going to give me. And if I just do the easy thing, like just echo out the $line variable, that would show me what's actually happening as my loop goes through all this. And then I'll end it with a done. So we'll see as I do this, if I got my syntax correctly, yeah. Now I can call this $line variable inside the loop. And this allows me to go through every single one of these things one at a time. And all that I did was echo it out just to confirm that it was working. And so my next step would be, okay, I don't want to just echo them out one at a time. I actually want to see, like, is this in the other file somewhere? And if so, like, where is it actually located? And so, again, some simple ways that you could search for this particular text is we're back to grep, right? Just doing a simple grep would be able to tell you, like, does this value actually show up in the actual encoded file that's kind of one per line? And that was what my message... what was it? Message dash encoded 2.txt. I'm trying to remember my file names here that I just created. Let's see if that actually works. Yeah, okay. So every single one of these means that we just went and hit this particular variable, which was every single thing in the secret one at a time, but it actually found them inside the message 2, that the one that was encoded. Now, the fun thing about grep is maybe now you could go and toss in those fancy line numbers that Mike was using out of looking at the data visually using the mousepad program. Okay, and a good way to do that is as part of your grep command, you can add on the -n option, and -n will add in line numbers. So now you kind of get that same result, but now I've got line numbers. I've got the line numbers now of where was this particular value that was in secret found in the library of values. Okay, in all of the values that were located in that original encoded message. So these were all the things Mike was kind of correlating one at a time, line 21, line 54, 7, etc., all the way down the list. So now the crazy part becomes, okay, can I take those line numbers and start identifying the results of all those line numbers out of my other file? And perhaps to just clean this up a little bit more, I don't really care about the value. What I really care about is the line number. So again, either using a command like awk or sed or something like that, or cut, maybe I'll cheat and I'll just use cut. That one's kind of straightforward. I'll take my grep result and I'll pipe it to a cut to be able to separate my data using the semicolon delimiter and take the first field, something like that. Okay, and again, like I said, I've got some videos that kind of go through using some of these commands like grep and cut, but here's where you can kind of get some other options. And effectively what I did was said, on the semicolon, just take the first field, the thing that comes before your very first semicolon, and then toss out the rest. I don't care about that. And so now I've got it restricted down to just those line numbers. And if your gears are cranking here, it's like, hey, wait, this is my new list. This is the list of things that I actually want. I want line 21 and 54 and 7 and all that. So all these things could be created as part of my list. And so that's kind of what I got by running this for loop. By running this for loop, going through one at a time, I was able to figure out what are all the line numbers that Mike was using to kind of correlate his values and find what the answers were for. And so now the crazy part becomes, well, can I go through this list one at a time? Can I take the result of this and actually go through this list one at a time and actually print out the values from the other file? Oh boy. So using this, it's, again, not necessarily the best idea, but actually the result of this for command could be sent into another loop that I want to go through one at a time. Yeah, we're getting a little crazy here, but that's kind of the point, where I could actually take this and say, how about I'll make this will become the result that I'll actually send in to some other for loop, like for answer in all of these individual lines, something like that. And then after all of this is where I'll have my do what exactly. And we'll see if I've got my notation here correct. What I'm really interested in is saying, can I get the line number out of the other encoded file that actually had all of my decrypted messages, the words that were actually in plain text.
Hmm.
And so, how do you print the line number out of a particular file? Again, there's a handful of different ways you could do that. One way that I'll use, I'm kind of on a SED trip right now, so maybe I'll keep using SED to be able to do that. But using SED, you can actually print line numbers out of files. And so, a way that you can print line numbers is to suppress all the other output and only print the line number that you specify. So, you can suppress your output by doing a -n, and then just inside quotes, you would want to put what is the number of the line and then a P that you want to print. Now, in my case, I don't want to print line 2. I actually don't want to type the lines at all. That's what I have this ANS variable for. So for every single one of these results, I'd like you to print that particular line number. So I'll say that as a $sign. In order to get it right next to the P, I'll use my curly braces, ANS, close curly braces, something like that. And oh boy, I've kind of run out of breadcrumbs here. What's the file that I want to grab this from? Message? I think this is
Message two, yeah.
message2.txt, and then I could try a done. And what are the odds that I've got enough breadcrumbs to find my way? I don't know. Whew. I mean, that's pretty close. If you remember, Mike said there were a couple repeated words.
Yep.
So any word that showed up twice in my message actually now shows up in my results twice. But now I'm kind of to that same point of count the number of words and send the number of words as text. I don't where did that go? I don't know. Something got cut off, but I got a pretty darn close. And so now the kind of question becomes, can I actually go back and get the answer that Mike had by figuring out, well, how many words were there? Again, you can use a command like word count. WC is a nice command for counting things. You can count characters, you can count words, you can count how many lines of text, etc. But you just have to specify each one. Like, are you counting characters? Are you counting lines? Are you counting words? Whatever. And I'm going to count those out of, what was that? My actual message.
Hmm.
My message.txt. That was the original. And so we're kind of getting to that same answer of, well, there's 64. All
Love
right.
it.
So, like I said, there is an answer that maybe has a little more chest hair and also is very prone to mistake and very prone to tangents, and certainly takes a lot of practice to be able to get to the point of, can I take a quick moment, write a loop to help me out and solve the problem? And if you feel like you're running out of breadcrumbs, take a deep breath. You probably are running out of breadcrumbs. Like, maybe just use the scripting to help you get part of the way, and then use some other way of looking at the data to help you get the next step of the way, the next step of the way, etc. So I don't know, Mike, am I crazy, or is this just is it helpful?
Your
I don't know.
approach there is generally how I would approach a problem like this. But I would team up with somebody that knows the scripting and the bash stuff way better than I do. And
Hmm.
I would just be like, hey, do you know how to do X, Y, and Z really easily without me having to go Google it for 3 hours? And if they can, great, then we kind of team up and take that approach. Otherwise, I would probably like hack through it the way you did and kind of just create intermittent files that kind of get me one step closer. But no, I think this is great. I love it. I love that it kind of correlated exactly with the way that my approach, just manually walking through it did.
Hmm.
And I'm glad that everything turned out the way it was supposed to.
Yeah,
That's a
exactly.
plus too.
Yeah, that's always a bonus. I definitely like your idea though of, yeah, it's solving the problem for the team, but doing it as a team, certainly makes a really big difference. If I find that as as the hacker, it's like, I just want to be alone over in the corner and work on this problem. And it's like, that might not work out as well as you'd like it to. So,
Isn't that the part in the movie where somebody just shoves you out of the way and then they bang in the two
oh,
commands
right,
and it's
right.
all done,
You need
right?
multiple, as many people on the keyboard as possible. That's right. The more you are, then yeah, then obviously you're gonna hack it faster. So yeah, that's not how it works at all in life. So perhaps I would toss out as a challenge, by the way. So this is kind of how I solved it the very first time that Mike showed me this problem. And I would toss out too that I did think like half a second after I did this solution to say, I can cut out one of these loops entirely if I end up using the paste command instead. So maybe that's my challenge for the next month, is to say, this by far not the most efficient solution to go from data to a refined, there's my 64 showing up on the screen, to say like, well, what could you do? Could you reduce one of my loops by figuring out a clever way to start pasting some of the information together in the same file? That might be a nice little thing that you could do. Maybe you'd use some other language to solve this in kind of a crazy technical way, but I'd be really interested to see what else other people come up with. Whether it's doing things by hand, doing things with Bash, Python, whatever. I always think that the more ways you can look at a problem, like that's one of the best things you can do to actually prepare for competitions, is just think about other people's thought processes.
Mm-hmm.
And as best as you can when you're doing that, this is the hard part I find for students, is try to talk while you're doing it. It takes practice to actually talk through what am I doing while I'm doing it. It's kind of can be difficult. You want to just sit there quietly and think, but if you're talking through some of this stuff, now the people you're working with can think, okay, is that a good idea? Is that a bad idea? Can I contribute to that good idea and make it a little bit better? So, well, that was a journey.
Yeah.
So perhaps from here we'll do something a little lighter. But there's sort of some crazy technical stuff here for today. I think the kind of the next place to go here is let's talk briefly about some funny things that happened at the competitions this past season. And I'll preface this by saying I listened in to all sorts of the regional competitions, all sorts of teams, got to talk to all sorts of students across the country. It was awesome. And there were some really genius moments that happened. There were some really bonehead moments that happened. And there was a whole bunch of funny stuff that happened in between. I captured some of it and kind of collected some of these things and tossed them together. And I thought it'd be kind of funny to come up with this little series that I'm calling Questionable Cyber Strategies. So I'm not saying that everything that I'm showing is stupid. I'm definitely not saying that everything that I'm showing is just a joke and there's nothing to learn from it either. All right. So there are some funny things that happen, but certainly I hope we can all have a little bit of a laugh. We can learn from this, and we can start to hopefully be inspired to say, okay, what can I do to, I don't know, maybe do an awesome job and end up on one of my questionable cyber strategy series. And maybe if you would prefer to avoid it, then maybe you can avoid some of these as well. So let's take a quick moment and watch some of the a little bit of footage from what happened with one of the teams at this past regionals.
That out of the way, it's an easy 100 points.
Where's the survey?
It's in the Google chat.
Okay.
I'm still doing this freaking survey.
Well, I think I didn't do this. I'm improving.
I really didn't want to do the survey, but okay.
I changed it to Team 9. Okay.
Mm-hmm. What can we do to improve? Nothing. It was great.
That's spectacular.
Awesome, man.
I was hoping to get trolled more, but that's okay.
All right, message heard. I'll go tell the red team.
No!
So we have some attack requests coming from Team 9.
Have what?
Team 9 was, I don't know, little on the sarcastic mouthy side. They said they were bored.
Bored? Their whole board is red.
Yeah, what are they bored with?
Just drop something in like red open or something like that, targeting Team 9. Be like, oh, you called?
Okay.
I'm gonna see if their router has a default password. Oh, it does. There we go. I turned the router off. That should
shut down literally everything.
Hold on. I'm gonna turn off their other server too here in a second.
I mean, I asked
Wesley,
for it.
You know what? You're changing the password on the shell. Have fun.
Yes. Yeah, I will. No problem. All right.
I'm a broken man.
And remember, it's reversed. So if you enter something reversed, it's reversed.
No more.
Oh, God.
I gotta see this.
Team 6 is using a botnet with AI. I don't know what they're doing.
Oh, the system on the router halted.
That's actually hilarious.
Wesley messed us all up.
Is your server even turned on?
Yeah, I got one trivia, guys.
It was halted.
It was halted, huh?
I'm pretty sure someone in the Discord channel said that they were expecting more trolling, and then we got trolled. And
That's what they do.
It's all good. I'll look into it.
Wesley, why did you do that?
Wesley.
That's okay.
Oh, Wesley.
Yeah.
Okay.
Go into your Proxbox interface, turn it off, and turn it back on. They've just stopped your system.
Yeah,
Oh, thank you.
All right. Well, hopefully they don't change my damn password.
All right, just shoot me a direct message if you want them to give you some more attention. I'll be back.
All right.
Wesley, you do that, you're getting 2 smacks.
Moving on to Team 9, Westchester Community College. Do we have some people from Westchester that are willing to chat with us for a few minutes? Looks like some Westchester students are nominating other people to speak at the event.
I'd like to speak. I'm from Westchester.
Go ahead.
Okay. So the good thing is that we had pretty good communication, and for the most part, we were pretty good at keeping our emotions in check. And we were like constantly reminding each other to stay calm, even when things were going totally wrong. And I will take personal responsibility for this. I accidentally asked for trolling. Don't do that. And I got our router halted as a consequence, which was very well deserved. So I was told I had to shut it down and start it up again to get it running, but it wouldn't shut down. So I needed help from Nick on the black team to kill it. So don't troll the red team. Learned a huge lesson there.
Well, we're glad to hear it. We really appreciate how hard you guys worked on this, and we're really glad that you had such a good day. So we are on to individual awards. So for Westchester Community College, voted most valuable teammate is you, Wesley Chu. Congratulations, Wesley.
Thank you.
All right. So, moral of the story, Mike. What did you gain from that story?
Well, I would be worried about you in the future here, James. With the team seeing you in there, they might not be as apt to disclose anything. But no, that was great. I only got to see it from the CTF perspective, so I didn't get to a lot of the input from the teams as they were going through the event. So yeah, it was interesting. It seemed like they took it, in jest there. It was still fun. I know that, if I were in their shoes, I would probably make similar mistakes. I have made similar mistakes. So yeah, it sounded like a lot of fun. I'm sure you enjoyed listening to some of that throughout the day.
Yeah, and I have to say for the record, so that I don't get fired or murdered or something, that definitely I did bounce around a lot to the team channels, and I certainly provided more help than I was more of a protagonist than an antagonist, let's put it that way. Definitely for any of the teams that were struggling throughout the day, I try to give them a push in the right direction, but when they ask for it, I mean, what am I supposed to do when they ask for it? So anyways, yeah, they did pretty well throughout the day. Definitely, I remember them specifically having a lot of friendly banter throughout the entire day at the competition. And I just want to emphasize, even when your teammates do questionable things, keeping a good spirit, keeping a light spirit, being able to joke with each other, like that goes a really long way. So some things you can do to help encourage that are, number one, remember that, as best you can, try to stay positive. But food and drink also goes a long way as well, so sometimes you get angry, you don't eat enough, and during competitions, things like that can happen too. So, but all in good fun. We definitely had a good time with that.
Looking forward to season 2, the reel from that, see who's learned their lesson or see what interesting things we come across.
Yeah, exactly. I seriously doubt that will be the last award that we coin here at the national competition. So kind of moving on to that, and perhaps something you can do as a quick sales advertising pitch, something you could do perhaps to not be on the questionable cyber strategies, is to practice, right? To practice a little bit more and to help practice more. Obviously, we've got some things here in our sandbox which have been great for that. I will continue to expand on the YouTube tutorial list. So the Sandbox tutorial videos, you can click on these and see the full YouTube list. If you're following us on YouTube, you'll notice I just released some a few hours ago. So hot off the press, if you go to the actual playlist all the way down here at the bottom, there are now some videos that also cover things like rsync, cron, and then the combination of rsync and cron combined with some SSH, to create secure backups using passwordless authentication. So I don't know, Mike, how does all that sound as feed for the kids? What do you think they can do with that?
I think that would be, very good content to go check out. I'd have to check, but I don't believe we've ever had a single team attempt to take a backup of their system at any point throughout the event, which has definitely had an impact on the events for those teams throughout the day. Once they've done something that's irreversible, they either have to start fresh or they have to recover from a backup. So just knowing how to set that up is going to put you in a spot to more quickly recover in the event that you either do something incorrectly or you get the red team on your case and they're a little too mean.
Yeah, very much a shaking my head moment when you say, yes, we're at a cyber competition. Did anyone do a backup? Well, I should do that, shouldn't I? Yeah, definitely a question. That is a questionable cyber strategy for literally everyone who went to the competition. So we did see some backups of stuff where people were backing things up locally. They had a copy in another folder. But those pesky snickering hyenas that we call the red team, they go looking for those things. They know you might have taken a few moments to copy some things and had a backup. So, maybe you should take it a step further, not just protect your system, but try to protect your backups as well. And, perhaps using some of these tutorials, using some of these videos, and then just using it as a starting point, right? I'm trying to open the door here for some ways to do things. I'm not pretending this is the only or the best way to do it. So, but try to consider that and how you might incorporate that into your team strategy. Definitely could save you some points and save you some headache. So, to kind of work towards wrapping things up, I want to emphasize that us here at NCAE Cyber Games, we care a lot, certainly about our Discord channel. We care a lot about our Sandbox. We care a lot, obviously, about this kind of live interaction that we can try to do, not just during the competition day, during when we're actually running our events, but kind of all season long, let's call it. And as part of that, anytime you can get either yourself or the or other students, other people who are on your team into Discord, that would certainly be great. And hopefully we can continue to grow this community. And some of the things that we're trying to do from a community perspective is provide you guys with a lot of the updates that are happening. Definitely one of the big things that we're looking forward to is deploying the ability for you guys as competitors and as players at our national games to be able to manage your own teams. But nevertheless, this is just one of, preview of coming attractions to be able to have some features and functionality, some profile stuff to be able to do a lot of that. But still, building community is definitely something that we're all about. And as part of that effort, something that I've started doing is going around and trying to have some conversations with students. Just this past week, I caught up with our local cybersecurity club, the one that I work with here at Mohawk Valley Community College. And so I spoke with some of the members of the club who are, a couple of them were previous competitors, a couple of them are going to be first-time competitors, and just got to chat with them a little bit. So I think it'd be cool if we can start to meet each other, since our event is so heavily on the virtual side, on the remote side. It'd be really cool if we can chat a little bit more through that. So, having said that, I'll share my little short conversation that I had with some of the club students, and then you get to meet some of the students here at Mohawk Valley. So, hello and welcome. My name is James Rice. I'm cybersecurity faculty here at Mohawk Valley, and I caught up with our local cybersecurity club here, the Cyberhawks. This is a club made up of all current students here at Mohawk Valley, and a bunch of us are former competitors, and some of us are first-time competitors, so I figured we'd get a chance to meet a few of them and see how their experiences are and see what they're doing to prepare for the upcoming season. So, I awkwardly got all of the students wonderfully on camera. Hi.
Hi.
How are you?
Hi.
Yeah, as you can tell, they're absolutely thrilled to be here. And this is the advantage of being their professor, is I get to force them to do things like this. Otherwise, I dock their grades. All right, so no, we won't be doing that. But hopefully we can have a little bit of fun. And a lot of them have been hanging out with me here in the lab after class to be able to just prepare for our local competitions, upcoming competitions, and all the above. So hello again to everyone. Maybe just some quick starts here. We're joined, at least front and center. We've got Nick.
Hello.
Hi, Nick. Nick is our president of our Cyberhawks, and so he is our fearless leader. And you are a returning competitor from last season. And so if anything goes horribly wrong, we are all going to blame Nick this semester. That's really what we've all agreed upon, and we're informing him of that right now. So having said that, Nick, what was it like to compete last year?
Last year?
Yeah, this past spring.
I don't think I did. Did I?
Yeah, you showed up with...
Are we talking about the NCAE?
Yeah, the National Hackathon.
Okay.
So, Nick, we're here today to talk about the national event that's coming up. And this is one that you competed in with a few other students. Some of them are even here in this room right now.
Oh, yeah.
Oh, yeah. Okay. This is very early in the afternoon for Nick, so we'll forgive him of such responses. But so, do you remember what it was like now? Are we ringing bells? The national event?
Yeah, it was pretty good. I was happy with the first half.
The first half? The first half of what?
Of the event, of the NCAE event.
So if I remember correctly, you guys were like nailing it in the morning.
They were killing
like
the
number one,
services.
number two, number three out of like 10 other teams that were competing. And then
then the break hit.
And then lunch happened. And I'm pretty sure all focus went really like downhill from there.
Well, it didn't go downhill.
Oh, it didn't go downhill.
It went to CTF.
Ah.
That's even worse than going downhill.
How so?
CTF isn't very useful for points if you don't know how to do them.
Imagine that. So you either get it or you get no points.
Yeah. It's fine, like, if you want to try to learn them, but there's such a time sink if you don't know how to do them in the first place, is a real issue with them.
So a lot of that was just like balancing what's the time you're going to spend versus like what's the payoff you're going to get for spending that time.
Yeah, exactly. I mean, if you have 8 people doing services the entire time and you're doing super well on services, why would you then take all 8 people off of services, go to CTF, and ignore services when that's when red team's really going to start attacking them?
Yeah, a little bit of strategy.
Yeah.
Now, who did you have in the room here with you last time?
I had...
Nate's
over here because he's feeling a little under the weather.
He's literally coughing and trying to muffle his coughs right now. So
yeah, I feel
but
bad.
he did join us. Thanks, Nate. Was there anyone else? Elias, did you join or you weren't able to last year?
I wasn't able to.
No, you weren't able to.
I was
so
looking forward to it.
You'll be able to make it this time around? All right, cool.
Yeah.
And we also got newcomers as well. The two of you in the front. Yes?
Yeah.
Okay. Looking forward to it, excited by it?
Oh, yeah, absolutely.
Okay. Which part? Have I told you anything about the event that you're looking forward to, or just no, I'm here and we're just going to see what it's all about? That works for me, so.
Going in completely blind. Yep.
You're going in blind?
Yeah.
Okay. So we've got between now and then to practice at least a little bit.
I'm hurt.
Yeah, or we're going in blind. And Nick says he's hurt because, of course, he's been doing a little bit of practice. But, well, I guess at least on the other side of things, just outside of the club, certainly you guys are doing some things to practice, like your classes. And I've emphasized that, the things you guys are doing in your Linux class is definitely directly relevant for the event. I've got, internet security with you, Abigail, so that's been something that you'll at least get a lot of those security concepts. Because you're coming to us from a different major,
yes.
Right? So Abigail is our, a programming major?
Yes.
Yeah, so we don't have necessarily all cybersecurity people, but that's good. So what is it about this cybersecurity stuff that you thought maybe I'll join and see what it's all about? Or because you're kind of coming from the programming side, not so much from the computer science side.
Well, because I heard about digital forensics.
Okay.
So I wanted to learn more about just networking and security and all that stuff. So I joined the club because of that.
Okay, cool. Yeah, and definitely the digital forensic stuff is usually one of the categories you're going to encounter at the CTF. So some of those CTFs that Nick said can be a big waste of time. You definitely can waste your time learning a lot, though, about a lot of the digital forensics, and definitely the networking will help out with that as well. So Dasha, any reason in particular why you're choosing to subject yourself to this wonderful pain that is the competition?
I heard you hyping up the club, so I decided to join.
Yeah, cool. And we'll see how it goes.
Yeah.
And Dasha, what, you're starting a new internship soon?
Yes, I
am. New job, so that's
Mm-hmm.
really exciting as well.
Yep.
Cool. In the back, we got Robin to here on this side of things. So what, did you guys compete last year or no?
Nope, no. Brand new.
Brand new?
Yeah.
So why the heck are you choosing to do this?
I mean, it's interesting. I'm looking forward to facing the red team.
Yeah, okay.
I'm confident.
Oh gosh.
Yeah.
He's confident going into the red team.
Don't show this to red team, please.
Just ignore that. He's new. He doesn't know what he's talking about. All right. So it sounds like a good idea, but anyways, we'll try to be nice to hear his first time. But let's just say we have a friendly red team. You know, they attack you with a smile. So, but that should be good. Rob, how about you?
I didn't go for my first year, but I was going to try this year.
Okay.
In hopes that I know more, even though I don't.
Okay. And behind you got some things you're practicing?
Oh, yeah.
What have you been doing to practice?
We were doing the different activities on the Sandbox.
Some Sandbox stuff?
Yeah.
Okay. I think last week they were messing with some of the Pac-Man ping stuff.
Yeah.
And they're messing with the mini hacks.
This was some capture the flag, and then...
Okay, doing some of the CTF.
Yeah.
Nice. And definitely, if you want to get yourself in the mood, you toss open some threat maps. I don't know if you guys can see that here, but behind them, like they just toss open random threat maps on screens that feel cool.
Vigilant.
That's right. We do oftentimes as the Cybersecurity Club here. We try to get things like hoodies. So then, of course, you can have your hoodie and you can have your ski mask for the day of the event. That's always good things to do with the pizza.
Mm-hmm.
So, but anyways, so this is us. This is the Cyberhawks here in Mohawk Valley. We'll have to see because we've got like 2, 4, 6. 7-ish. I think the max team size is like 10 or 11. So if we can have a couple more people that can show up by spring, that'd be great, you know, to get a full team of 10. But if not, you know, we'll see how it goes and just continue to practice from there. So anything else you guys want to say? Kind of want to share? I don't know if I had other questions I was going to ask.
Red team, I'm coming for you.
It's on.
This is not. It's not. Abigail, you have to tell them to stop. Okay, so someone on the team has to be the voice of reason. And what I'm establishing here is it's probably not going to be anybody to your right. All right, so we'll toss that out there that someone should step up and be the voice of reason. So, but sounds good.
Yeah.
All right. Look forward to meeting some of the other teams, and can't wait to see what the next this next competition season brings. All right. We'll see. So, Mike, that was our Cyberhawks. Have you met any of them before?
I think only virtually, not in person. I foresee a Nick Award coming this year, maybe.
the Where Am I? Oh yeah, I'm here scoring a lot of points for my team. That's where I am award.
Yeah, and also taunting red team. That'll be interesting. We gotta keep that away from Brody, I think.
Exactly. So, well, anyways, like I said, we've been talking here for a while, so why don't we try to see an end to here in sight and tell some of our viewers here what they can kind of do to contribute as far as community is concerned, and see what we can look forward to next month. So just as a quick follow-up to that video, like I said, it'd be great if I could touch base with some more clubs. Maybe if you're watching this and you're one of those clubs, you want to make your own little video and just share it with us. I think that'd be really cool to just continue from a community perspective and see what we can really build here over the next few months. And it's always great when you go and show up at a competition and actually see some familiar faces, even though you're competing with people across the country. So, Mike, do you want to give a quick outline of kind of some of the things that other people can do to contribute here between now and next month?
Yeah, as James said, we'd love to get a video for that. I want to hear more from any students that are planning on competing on different CTF topics that you might want to have covered. I'm happy to kind of do a demo or a run through of a challenge, either that we've used in the past or last year or something like that, to go over just like a different topic, a different concept, things like that. I'm interested to help out in whatever way I can, either here or on Discord. But our plan is to go through a different challenge next month, and we're going to take the feedback from anybody that's watched this now or is watching it later into consideration for planning for that. So let us know.
Yeah, that sounds awesome, and definitely anybody who wants to see some of the other challenges and start wanting to think about contribution, I will just kind of plant that seed in your head that, Mike is definitely the best person to talk to about that, whether you're a student or faculty. We do have a capacity to try to accept contributions from the community. We're definitely all about that collaboration word. So that's something I would really just kind of challenge everyone to consider. So, having said that, I think that's a good place to kind of end things here for this first run. So, for the rest of you guys, just hit us up in Discord. I hope to see you all in the Sandbox, and look forward to seeing how things go next month. Mike, thanks for joining me. Have a good night. We'll see you next time.
See you next time.